Now we are going to discuss about mass rainfall curve and hyetograph. Why we are going to discuss about these two heads? Mass rainfall curve as well as hyetograph are used where we are going to discuss about infiltration studies and hydrograph analysis. What is mass rainfall curve? Mass rainfall curve is the plot between the accumulated rainfall versus time. Here you see the diagram here. This is the time. This is the accumulated rainfall. Because this is the accumulated rainfall, the rainfall is increases with respect to time. This graph is known as mass rainfall curve. So already we discussed about rain gauges, automatic rain gauges as well as non-automatic rain gauges. In case of automatic rain gauges, we got directly this mass rainfall curve directly from the automatic rain gauges. Whereas in case of non-automatic rain gauges, that rain gauges gives only depth of the rainfall, so that we can't get directly from the non-automatic rain gauges. In this condition, we should know the beginning of this drum and end of this drum and also rainfall depth. By using this duration and rainfall depth, then we are going to prepare the mass rainfall curve. Then what are the purpose of mass rainfall curve? This mass rainfall curve is generally used for the storage of determination of amount of rainfall and duration of rainfall and intensity of rainfall. So this definition indicates that directly gives the duration and amount of rainfall. But this is also used for the determination of intensity of rainfall. So, but this intensity of rainfall is calculated by tangent to the mass rainfall curve at any point gives the rainfall intensity. Next one, hyetograph. Hyetograph is the bar diagram, average rainfall intensity versus time. Here, how to construct the this hyetograph? So for this, we should know the intensity of rainfall. This already we have discussed about that mass rainfall curve that gives intensity of rainfall, but the tangent of the mass rainfall curve gives intensity of rainfall. That rainfall intensity is not used where we are going to construct the hyetograph. Here, that intensity is determined, that intensity of rainfall is determined by giving the constant time intervals. Depends upon the duration of the rainfall. That constant time interval should be fixed with respect to duration of the rainfall. So, once we fix the constant time interval, that is known as dt, and corresponding rainfall increment, that is denoted by dp. Then we are going to estimate the rainfall intensity equal to dp by dt. Just I will show that one example problem. A rain gauge recorded the following accumulated rainfall during the storm. Draw the mass rainfall curve and hyetograph. So, for the preparation of mass rainfall curve, we should know the accumulated rainfall with respect to time. They have given directly accumulated rainfall, that is 0 at 8 hours, and after 5 minutes 1 mm, after 10 minutes 2 mm. This is the cumulative rainfall, accumulated rainfall, and after 15 minutes 6 mm, 20 minutes 13 mm, after 30 minutes the rainfall intensity, the accumulative rainfall depth is 19 mm. So they have given directly accumulated rainfall and also given time interval. Based on these two readings, we are going to prepare the mass rainfall curve. But for the preparation of hyetograph, we should know the intensity of rainfall, because here they have not given intensity of rainfall. For that, we are going to estimate like this. So they have given the rainfall 8 hours, after 5 minutes, and 10 minutes, 15 minutes, 20 minutes, 25 minutes, and 30 minutes. So based on this time, we are going to separate the time like this, or we are going to fix the time interval based on the given duration. Here, 8 to 8:5 is 5 minutes span. 8 to 8:5, this is 5 minutes span. What is the 8 o'clock to 8:5? The rainfall intensity, incremental rainfall is 1 mm, right? 1 mm. Then 8:5 to 10. 8:5 to 10, 8:5 to 10, the span is 5 minutes, constant time interval, 5 mm, 5 minutes. 8:5 to 8:10, the incremental rainfall equal to here 1 mm, here 2 mm, the incremental rainfall is equal to only 1 mm. Then 8:10 to 8:50, The span is 8:10 to 8:15. The time interval is only 5 minutes. The time interval is 5 minutes. But what is the incremental rainfall? Here this is 2 mm at 8:10, 8:15, 6 mm. The incremental rainfall equal to 4 mm. Like this we have noted here. 8:25 to 8:30. That means 8:25 to 8:30. The rainfall depth is 18 mm. Here 19 mm. The incremental rainfall depth is only 1 mm. So this entire row indicates the incremental rainfall. This is the time, and also we are going to estimate the intensity of rainfall. For the preparation of hyetograph, we should know the intensity of rainfall. That means average rainfall intensity versus time. So that we should calculate the average rainfall intensity. Here 1 mm, that you convert into mm per hour intensity. 1 divided by 5, that means 5 minutes into 60 converted into hours. That means 1 by 5 into 60, we have 12 mm per hour intensity at this 5 minutes interval. This 5 minutes interval, the intensity of rainfall is that 12 mm per hour. The average intensity 8:5 to 10. Average intensity of rainfall is 12 mm. Average rainfall intensity 8:10 to 8:15 is 48 mm per hour, and then 84 mm per hour, 60 mm per hour, and last span, that is 8:25 to 8:30. Within the 5 minutes span, the average rainfall intensity equal to 12 mm per hour. Then based on this, we are going to construct the bar diagram of hyetograph. Here, first span is 5 minutes. That means 0 to 5 minutes. 0 to 5 minutes. The average rainfall intensity is 12. Already we calculated earlier. Then 5 to 10. This 5 minutes span, the average rainfall intensity also 12, and 10 to 15, average rainfall intensity 48, 15 to 20, average rainfall intensity 84, and 20 to 25, 60, and 25 to 30, 12. This is the hyetograph. That means time versus average rainfall intensity. This is nothing but hyetograph. This is already we discussed. This is the mass rainfall curve. These two heads are used where we are going to discuss about infiltration studies. Now we are going to discuss about runoff, estimation of runoff. Any stream or reservoir having their own catchment area. Here the total quantity of water drawing into a stream or into a reservoir from their catchment area is known as runoff. The runoff is expressed in centimeters, or the total quantity of water is expressed in meter cube or hectare meters. Already I told you the rainfall is divided into different groups. One is evaporation, surface runoff, subsurface runoff, and groundwater flow. Here factors affecting the runoff. These are the factors affects the runoff. First one is precipitation. Here, if the intensity of rainfall is high and the duration of rainfall is also high, that gives high direct runoff. And shape and size of the catchment. Here, the runoff of a catchment also depends upon the size, shape, and location of the catchment. Here, more intensive rainfall are generally affected on a small catchment area. Automatically, the runoff or the water reaches to that stream or the reservoir is high. That means the runoff is more. Or otherwise, if the rainfall intensity is uniformly distributed over the catchment as a large area, the runoff will be less as compared with the earlier situation. And also the runoff depends upon the size, shape. This is shape of the catchment. Here the shape of the catchment is pan-shaped catchment. This another one is the fern-shaped catchment. Here you observe one thing. This is the stream. Here in case of pan-shaped catchment, the tributaries are almost all equal distances. In this case, once the rainfall falling over this catchment area, The water reaches from this point to this point takes 1 hour time. For example, if this point to this point also takes 1 hour time, this point to this point also takes 1 hour time, because the tributaries are equal lengths. So that the runoff into a particular stream is too high, whereas in case of fan-shaped catchment. Whereas in case of fan-shaped catchment, the tributaries are having different lengths. Here, this is length of the tributary, large length is too high as compared with this length. Here having different lengths of the tributaries. That's why this point to this point the water reaches takes 1 hour time. In case of this tributary, this point to this point, that will takes 2 hour time, because the length is more. That's why in this case of fan-shaped catchment, the runoff is not having a high discharge. Right? Tributaries are generally different lengths in this case. That's why the peak flood intensity is reduced. And another one is the topography. The runoff of a catchment is also depends on the topography is smooth or rough. If the catchment area is having steep slopes, automatically the velocity is too high. In that situations, automatically the evaporation losses also less, therefore the runoff will be high. Whereas in case of the rainfall is distributed in the mountains catchments, there is also having high floods, that means having high runoff. And next factor is geological characteristics. These are also very important factor to decide the runoff quantity. Here the surface soil, subsurface soil and type of rock and their permeability characteristics gives the rate of runoff. So if the soil and subsurface is pervious, that means sandy soils available on a particular catchment. At that particular case, the seepage losses are too high, seepage will be more. Once the seepage is more, that means infiltration water into the ground is more. What is happening? The runoff will be less. So that in case of pervious soils, the runoff capacity will be less as compared with the impervious layers. If the surface is rocky, that means this is impervious layer. Here, the infiltration capacity of the soil is almost all zero. The X quantity of water coming from the atmosphere, the entire water is directly converted into runoff. That means X quantity of water flows above the ground surface, because that is the rocky foundation, rocky layer is there. There is no infiltration capacity, there is no chance to infiltration water into the aquifer. At that conditions, the runoff will be more. And meteorological characteristics, you know what are the meteorological characteristics? Temperature, wind and humidity. These also affects the runoff of the catchment. And also character of the catchment surface, that surface is dried or undried, natural or cultivated, or whether it is exposed to or exposed or covered with the vegetation. These also affects the runoff of a particular catchment. So here computation of runoff, our aim is to determine the runoff of a catchment, runoff of a particular catchment, runoff of a particular stream or reservoir from the catchment. This runoff can be estimated daily, monthly or yearly based on the requirement, depends upon the requirement. Here for the estimation of runoff, here generally we can use these formulas. One is infiltration method, runoff formula and tables, and unit hydrograph method, and last one is the rational method. So come to infiltration method. This is already we discussed in the earlier class. That is what is infiltration? The quantity of water enter into the soil. The remaining water flows above the ground surface. So here what we learned based on these infiltration studies, and also we discussed about pi index and W index. Pi index represents average rate of infiltration entering into the soil. Once we know the average rate of infiltration, definitely we are going to estimate the runoff, because the rainfall divides into two groups. One is infiltrated water, another one is flows above the ground surface. Therefore, the runoff volume, the runoff of water equal to precipitation water minus infiltrated water. How to determine the infiltration capacity or infiltrated water? Already we discussed in the where we have discussed in the pi index and W index. That is clear. Next one is runoff formulas. Here runoff formulas, here they have used one equation. This is equal to R equal to Kp. So this is also runoff coefficient formula. Here what is the relation in between the rainfall and runoff? We know we are having, for example, 10 centimeters of rainfall on a particular area. Out of 10 centimeter rainfall, some quantity of water infiltrates into the ground and some quantity of water flows above the ground surface. But that flows above the ground surface water should be less than the rainfall intensity, less than the rainfall capacity. Therefore, we should introduce one constant that is known as K, that is runoff coefficient. Therefore, runoff depth R equal to K into P. P is the precipitation, R is the runoff, K is the coefficient. This should be always less than 1. If suppose this K equal to 1, what is happening? The total precipitation may be converted, the total precipitation converted into the runoff. Therefore, this should be less than 1. This is also depends upon the type of soils or type of the surface layers. Right here, you know the runoff is expressed in centimeters or precipitation expressed in centimeters, and also K is the runoff coefficient. The runoff coefficient is naturally depends upon this. All these factors what we have discussed in the earlier, that means precipitation, temperature, geology, all these affects the K value. So here some values of K of varies with respect to type of surface layers. Here urban residential areas, in case of single house residential areas, single house, the K value may be taken as 0.3. That means, for example, 10 centimeters of rainfall, R equal to Kp, R equal to 0.3 into 10, we have 0.7 quantity of water flows above the ground surface. Here this is the K value of different type of layers. Here in urban residential houses, K value for single house is 0.3, in case of apartments 0.5. That means K value increases, what is happening? Direct runoff value should be increases, right? Whereas in case of commercial and industrial areas, the value of K is 0.9. That means this is almost all equal to 1. Because in case of industrial areas, the entire area is covered with impervious layers. Once the surface layer is impervious, there is no chance to water entering into the ground. In that case, the total rainfall may be converted into runoff. So that here in case of industrial areas, the almost all the rainfall will be converted into runoff. And another one, forest areas, this the value is very less, because here the infiltration capacity is too high. In case of these conditions available on a particular area, the runoff will be very less, because the total rainfall, most of the rainfall depth infiltrates into the ground. The quantity of water above the ground surface is very less in case of this type of areas available. Whereas in case of parks and farmlands, in these cases, this is also very less K value. Here also the infiltration capacity is too high as compared with this commercial industrial areas and residential areas. Here also runoff is less. Whereas in case of concrete pavements, this is also almost all industrial areas. Concrete pavements means that is also impervious layer. Here the K value is 0.85. Here the infiltration rate is very less as compared with the earlier two cases. Therefore, the runoff will be more.